All right, thank you. Well, thank you everyone for being here. I'm very happy to be here. And thanks for the organizers to invite me. So my name is Etienne. I'm co-founder and CEO of NuMind. And we are a startup. In a sense, we are an LLM provider, a bit like OpenAI or Anthropic, although we're a bit smaller at the moment. And our particularity is that we are specialized in information extraction from documents, which means that we create LLMs that are specialists at extracting information from documents. And of course, the point of doing that is that these specialized LLMs are better than generalist LLMs at this task, as the title indicates. So to start, what do I mean by the way, you're going to be spoiled a little bit. There's always a title of the next slide, but anyway, it's resolution of this screen, I think. We cannot do otherwise. So what do I mean by extracting information? There's kind of two tasks. I mean, at least we separate it into two tasks. One is extracting structured information, and I'm going to talk a lot about that in this first part. And another one is extracting the entire content that we call content extraction, which is more akin to OCR for images. So first, structured extraction or structured data extraction. The point is to extract, I don't think oh, no, it works, it's back, okay. I think it's the wire that I'm touching here. Okay, so the point is to extract a JSON from a document, which can be an image, like in this example. It can be a PDF, or it can be an Excel spreadsheet, it can be text, an email, that doesn't matter. And extracting this information according to a specific structure. We call it a template, but it's like a schema of an API. And for example, you would ask, well, I want to extract the last name, I want to extract the first names, document number, I want to do a classification, male, female, other, I want to extract a date, things like this. And then this is used to fill up a database and to enter the workflow of the company. So typically it might be, a bank or an insurance company or an hospital or in the logistics. There's several industries, and they have incoming document and they need to do this data entry. So historically it's by hand. It's people in front of the computer that are, the pay stub, the invoices and so on. They're filling it up by hand. And that's what this thing automatizes. So it's automated data entry, this task. And okay, we're gonna have a little bit of a drop sometimes. I don't know where the false contact is. Yeah, as I was saying, there's many industries. It's a bit everywhere. I must say the biggest one, for example, the biggest one for us, it's banking, it's insurance, logistical as well, and healthcare. That's kind of the big four, I would say. At least that's. We know that sometimes there's some industry that are a bit, that will come a bit later. Like, I think healthcare is a bit behind the last three because maybe they want to innovate a bit less. I mean, it's important stuff, so they want to make sure the technology is very ready to use kind of these new technologies. Okay, so yeah, let's talk about the solution. So, really, what's happening right now, if you go in a bank, an insurance company, like this sort of companies, the way they do information extraction, this structured extraction, is via classic OCR methods like Tesseract and things like that, these deterministic systems that really recognize the characters. And then you have some handwritten rules, some classic programming for very specific use case. They might have a specific pipeline for ID cards of this country, and even this version of the ID card of this country. And of course, you find also machine learning models that are trained for very specific use case. They're generally tiny models that work well when it's a tiny use case. If it's ID card of such country, no problem. But they take time to create. You need data scientists, you need a team to assemble data, to train the model, to put into production, and so on. And typically it's 6 months to 1 year project to have something that works for a very particular use case of extraction. And then, of course, you have humans, which are heavily used still, because you might not want to, spend 1 year for every use case you might have for extraction. And this is like humans that do data entry, either in the company, internal, or via BPO, in country where labor is a bit cheaper. So yeah, that's the workhorse of information extraction at the moment. And then you might say, yeah, but I mean, something has been happening the last few years. Now we have ChatGPT, we can do, and many other LLMs that can do impressive things. They can code, they can write, things, so maybe we should just ask this AI to do it. And you've been spoiled, but LLMs are not yet perfect. Which is a bit surprising, because information extraction doesn't seem like a complex task. It seems easier than coding. But the fact is, they are not that good. And this is a list of the typical shortcomings. When you have complex layouts, such as tables, or several tables, or a table that is cut, beginning on one page and then next on the other page, and you don't have the headers that are repeated, LLMs often break down, even the best one, even the biggest of the biggest provider. If you have two tables next to each other, they might think a line, it's the same line of the same table. Actually, no, it's two tables with different things, and things like that. Actually, complex layout is often catastrophic failure. But anyway, long documents also, when they go too long. We all know it's not specific to information extraction. When you have long context, they tend to be less performing, but that happens here as well. And writing, of course. These humans are still in the lead for handwriting, for sure. When you have long extraction list, okay, that's super simple case. You go to the Wikipedia page of the list of the largest cities in the world, and you ask an LLM, any LLM, extract all the cities in this page. Absolutely all of them, even the footnotes and so on. And even the best LLM, they miss 20 of them out of 130. So they're like 85% correct, which is surprising. It's a simple task. But that's the way it is. And okay, checkboxes on forms, when you have texts that are sideways, So yeah, it's not perfect. And not being perfect is okay, but the problem is it cannot tell you when they are confident or not about what they produced. And this is a problem because you cannot have, it's difficult to have a human in the loop that can quickly correct what an LLM already did. And because of this, the pattern that we see is that this group, insurance, banking, and so on, they try LLMs, they do, little POCs, and they're like, hey, it's not there yet. It's not there yet. We stick to our old way of doing it. And, but us, we think there's a solution to switch to this new technology, which is task-specific large language models. And this is a bit of a diagram of how we create. It's a bit simplified, but I don't put the post-training with reinforcement learning and so on, but that's the basics. What you do is that you start with a generalist LLM, okay? And then you train it, you continue training, you fine-tune it with a data set that is, that shows examples of this task, which is a structured extraction task in that case. So typically, you might want something like 1 million extractions. So a bunch of extraction problems, like you put CV and we want to ask this on this CV and that's the result, and we put invoice and we want to ask this and that's the result, and you do that for as high diversity of documents as you can. And then you train the model, and you have your specialized model that then is very good at extracting information from any kind of document. So it's a specialized in extraction, but generalist in the domain, the kind of problems you might throw at it. Yeah, specialized but general in a sense. But of course the question is how you construct this magical data set, right? That's not easy at all. And for this, historically the first model that we call NuExtract, by the way, NuExtract 1 was very close to distillation. Like we took the biggest LLM we had at the time, and we made it we created a corpus from, from common crawl, and we made the LLM generate templates. So what could we extract from such documents? And then we made the LLM actually extract the information, and that was our data set. Over the time, it changed a lot. Now it's not distillation anymore. There's still a part where we take real data. You need real data to capture the reality, the complexity of the real world. And then you manage to annotate, but you can do several passes. You can do filters, you can iteratively correct the results. So there are ways to have a data set that is much better than the best LLM out there. Also, what you can do is you can make the task more complex after. You take an LLM that is not necessarily the best, and actually now we don't even use the best LLM. You can use open source LLM that are not the best, and you extract information from the document, and then you complexify the task by reducing the resolution of the document, by making rotate, by doing some transformation like this, or by taking two documents and putting them together, because it's harder to extract from two documents than from one. So you can artificially make the task harder to get a data set that is difficult for to really improve. And you can also create fully synthetic documents. And it's pretty easy to make very hard, fully synthetic. You cannot have high diversity with synthetic document. It's very hard to have diverse, the real world is top diversity. But you can make tasks that are very hard. You just put the characters very small, you can do a lot of things to make a hard document. And maybe I say too much, some of it should stay secret, but that's kind of what it is nowadays. It's a mix of real-world data and synthetic data to create this data set. Okay, and you might ask does it work? And the answer is yes. This was a benchmark of 7 months ago, which is very old by today's standards. So you might see that the models we compare are kind of the old generation, but that's what we obtained with NuExtract 2.0 Pro. That's, by the way, the way we work is the Pro version, our proprietary model, and then we have the smaller ones that are open source, all MIT licensed. You can use them as much as you want, that are distributed on Hugging Face. And yeah, it turns out that this model is much better than the generalist. These are the non-reasoning model, by the way. These are the ones that just spit out the answer straight away. Same as our model. That's why we compare to them. When we compare to reasoning model that cost 10 times more because it's a massive thinking trace, we got similar results. We're still a bit better actually, but clearly reasoning helped for that. And yeah, so it's better, but it's also smaller. This model is, we don't know the size of these guys, but about 50 times smaller than these guys. And so that's nice because then you can deploy it privately. And by the way, that's our business. I'll show you our platform. We have a SaaS platform people can extract, but many of these companies that I mentioned, bank, insurance, and so on, they want private usage because confidentiality of the data, of the documents. And so we made a model that fits on one GPU, so we can deploy it easily. That's the whole point. And yeah, actually, okay, that's what I talk here. That's NuExtract 2.0 generation. By the way, we have a 3.0 that is coming in the following weeks. And these are the open source ones. That's a Pro one, and that's the kind of GPU you need. So L40S, or A100 or H100 is completely enough to run it, whereas this guy requires a lot. And of course, energy consumption is a massive difference as well. Although not as big as the size because they're pretty good at doing mixture of experts. So it needs a lot of GPU, but to run it's a bit cheaper. And we are going there as well, actually. And yeah, and so we created the NuExtract platform that we released 7 months ago, at the same time as NuExtract 2.0, that I could show you a little bit. And let's take a simple use case of ID card because it's simple, even though there's nothing so impressive about this one. Let's duplicate it. These are the reference project. You can see a little bit what we can do. So yeah, you define the template. I can modify it. I can basically, yeah. You can have optional instruction. We added that last week. This is sometimes people, they wanted to define, well, the first names, be careful. What I mean by first name is this. When there's a composed name, actually separate them. Like you can give a bit of extra instructions. But the core is this template. You have types as well. That's an interesting one. Verbatim string means that the model should do a pure extraction. The model should copy-paste from the document. It should not reformulate. It should not like reformat, which helps to reduce hallucinations. And then you have other ones like date time, which is ISO standard. Here you have a classification. Actually, I mentioned that before. And this string, because it's the ISO code of the country, so of course it's not written verbatim in a document, so you allow the LLM to generate it. And yeah, okay, let's launch it. I'm gonna launch. So this is a very clean ID. There's really no problem with this stuff. But even when things that are not as clean, or things with shade and so on, that's where these LLMs shine, by the way. And that's where more traditional pipelines have issues. You can have occlusion, you can have different lighting and so on, and it's pretty resistant to this stuff. And I mean, there are more details, like you can put examples. So I could say, actually, this guy, I'm not so happy with the extraction. I wanted Maëlys and Gaël to be two separate for some reason. And so here I corrected it, and I put it in these examples. And the LLM used that as examples, like a bit like traditional machine learning, to improve its extraction. It's actually using in-context learning. It's putting the example in the prompt of the LLM. And then when you're happy, you have an API. And so you can, it's an asynchronous API. You send a file, you create jobs, you can pull them, and yeah, that's how it works to use it. Okay, and I guess I'll talk about that after. So yeah, that's basically for the structured extraction and for the platform. And yeah, as I was saying here, we deploy this platform privately at companies. That's mostly, that's our main business. Although we hope that the SaaS will become our main business as well. It's always nice to have a SaaS that works well. But it's a lot of enterprise AI at the moment. And yeah, so second task, content extraction. This is not the task that we are historically in. But we saw there was a lot of demand. Like, the open source models, for example, until very recently, we were the only one for the last almost 2 years with models that are specialized in structured extraction. But there's been a lot of OCR model out there. And we're like, well, maybe we can use our expertise to do an OCR model as well. And so we wanted to do something a bit different. So by the way, first I define the task. So the task is to extract the entirety of the document. There's no template. It's super easy to use. Actually, that's why these models are so popular. You just give the document, and that's it. There's no input except the document. And it provides a text-based output, like Markdown. Markdown is good, but there's other formats you could have as well. And by the way, the need for this is for a RAG application. Basically, when you create a local ChatGPT of an enterprise, you need to process all the documents into some common formats so that then you can do some search over this document. You can do some semantic search, of course, by chunking and embedding all the chunks and so on, and then provide the result of the search to the LLM. So it's a pre-digestion in a sense for LLMs. Yeah, and so yeah, we thought, what can we do about that? And so we noticed that these OCR models had a lot of trouble, and even the biggest model out there, with complex layouts. The one I mentioned before, when you have tables, when you have several tables, like catastrophic crashes. And so we realized that in order to improve for this kind of documents, and actually I'm going to start that already, because, oh dear, okay. Okay, maybe the demo is going to be for next time. I don't know how to restart it. I wish I had one of the machine learning engineer here. Okay, anyway, maybe I will. Okay, I don't think I will show the demo, but basically what we realized is that what needed to happen was for the model to do reasoning before, to have some thinking trace before actually answering, and not any reasoning, a reasoning that is targeted for extracting information, like thinking about the layout, thinking like, what do I see in the document? Oh, there's 3 tables. Okay, and what are the headers? Oh, is that? What should I be careful of? I should be careful of this column that splits, of this line that is, So, and that's what we did, and we created the model NuMarkdown. And it turned out it was a massive success 3-4 months ago, and it got a bit forgotten, and now it's again a massive success. We had 1 million downloads last month, and we got #1 in OCR models for like more than a month, and we've just been dethroned, and we are #2, which was completely surprising to us, because honestly, it's experimental, and like these guys, they train on maybe, okay, I'm going to say 10, but it's probably 100 times more compute. Actually, we know, the Lighton one was like on 100 times more compute than us. But anyway, so it was pretty popular, and I'm going to show you what it does. So it's, it's documents like this. Like you have a table that is cut. The headers is there. Or you have, this takes 3 lines, right? On the columns, this takes the full column. So it might believe that this actually belongs to the next column. This sort of thing that throw off the LLMs. And so our model has this thinking phase, analyze the overall document structure. Document consists of 2 main sections, containing a header, blah, 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 blah. It goes from the general to the specific. And it's pretty concise. Like if you ask, GPT, Claude, Gemini, to extract information from documents with the reasoning, it's going to go in all over direction. It's going to write pages and pages and pages and pages. So it's pretty concise. Doesn't take too long. Actually, it's as big as you see, as big as the output. And then it outputs the markdown. And it works pretty well for this kind of documents. At the time, we were beating all the specialists, GPT-4o at the time. And Gemini Flash was like competing, actually, is a bit better. Gemini Flash is a bit better. But like it's pretty close. And this was an experimental model. And now we are in the last stage of doing our, let's say, production model, like a pro model. And we are going to release it on the platform. So we hope that in a few weeks we'll have like a really, really good OCR model as well as a good structured extraction model. And so we call it NuMarkdown. And maybe to finish a bit on the roadmap, we actually decided to merge the structured extraction and the content extraction in the same model. It simplifies everything. Actually, we realized that the tasks helped each other out, so because they're so similar about the understanding of the document. And so, we're on the last stage for NuExtract 3, which is going to have reasoning, instructions, you already saw it. Actually, what's running on the SaaS is an early version of NuExtract 3. So, it's not finished, but it was already much better than the 2.0, so we put it up. Merge with NuMarkdown, okay, new types. And actually, no uncertainty, I made a mistake. This is, there's already, NuExtract already has a way to assess if it's confident about the entire document, about the entire extraction. But we want to go further and have NuExtract says, this value, I'm sure, this one I'm sure, this one I'm certain, this one I'm not sure, and so on, like value by value. And that's what's going to be NuExtract 3.0, along with handling documents that are arbitrarily long, with a sliding window. And actually, we might do something else, but yeah. And localization, also that the model tells where in the document, what kind of information it got to be able to answer like where in the document is this information, basically, which is asked a lot by our customer for human in the loop, both uncertainty and localization. Although our philosophy, I mean, we are doing this, but we hope that the model at some point is so good that there's no need for a human in the loop. And actually, that's the goal of NuExtract 4. NuExtract 4, we estimate in 8 months, and it's going to be something that has, agentic extraction process where if the model isn't sure, it can think more, of course, but it can also zoom on a document, it can do some rotation, it can do, call some tools, possibly some other kind of tools, we are thinking about that. And so yeah, it's heavily related to tool use. And we believe that this thing that will reach what we call, a bit as a joke internally, AGE, Artificial General Extraction. And so, yeah, we believe that it's with this sort of thing that we will reach AGE, and our goal is to do that this year. And because, I mean, we saw business-wise, if you have a model that you don't need to do customization, you don't need to fine-tune and so on, you just tell it what to extract, maybe a few instructions, like template, few instructions, maybe one example or two, and it does it as good as a human. So that's our goal. All right, thank you very much. And I would love to answer some questions.
Thank you so much. Really nice talk. Hopefully, NuExtract 3 doesn't get easily defrowned from the leaderboard. All roads to that. This is probably like an edge case question. The training data sets that you mentioned, I'm assuming like handwriting is probably the most hard to train your models on. So what sort of representative data sets do you use? Because I'm thinking let's say if it's like a doctor's receipt or if it's like a raw VAT receipts, some people write on paper, and then to combine that with the intersectionality of multilingual, a lot of languages, a lot of dialects. So how do you firstly optimize for that? And any industry that you go to or any clients, can they upload their own customized training sets to train your model?
Okay. I like this question. Yeah, so handwriting is a very hard thing. It's not where there's the most demand, however. It's not that common in writing, although it happens, of course, in forms and so on. But what you can do to create data set is to is to make it harder in a document after the fact. Like if you take a reasonably good handwriting, you make it extract automatically by some system, and then you can do some deformations, the contrasts, things like that. And that's a way to create a data set that is quite hard to train, and so there's something to learn to the model. Because if it's too easy, there's not much to learn, So yeah, that will be for the first question. And wait, what was the second question? Was
can clients upload their custom?
Oh yeah, okay, yeah. So because we are not AGE yet, that's what we do with our customers often. But it's not like before, where you do one fine-tuned model for every task, and the model does only this. We keep the generality of the model. So we have a NuExtract, and we gather data from variety of use cases from the company, and we train on this use case, and we also inject some of our data to make sure it keeps generality. So it's like a NuExtract for such and such, we like to give them little names, so it becomes kind of the model of the company. And it's pretty nice because they can still, use it, for everything, But it's a bit of a hassle, of course, compared to just having a model out of the box that just works. So that's our goal.
Thank you for sharing. I have two questions. The first would be, why do you choose to focus on the problem of extraction in the first place? And And then the second question would be, how would you define success for 2026?
Oh yeah, we chose it a bit because, I mean, I've been doing NLP for, I don't know, 12, 13, 14 years. So I'm biased toward extraction because the only thing that was possible at the time, right? And so when we started NuMind, we didn't intend to be LLM providers. We thought there's plenty of great open source LLM out there. We're just going to build a tool to use these LLMs. And at the time, it was before ChatGPT and so on. We were like, well, classification, entity recognition are kind of the natural tasks that we can solve now. That's why we focused on that. And then many things happened. I mean, ChatGPT, of course, happened. But also we realized that the model were not so good open source, so we started making them, and we saw they were very popular. And we're like, okay, we need to change. So we actually pivoted about a year ago. And we ditched our previous, it was a desktop app for data scientists to build a model on the, with small models like BERT type model. So yeah, that's the story of why we went there. I mean, we thought a lot, like, should we go into this, of course, RAG application and all this new kind of application that were opening up by this new technology. But in the end, we're very expert in extraction, and we're like, okay, let's focus on our expertise and use this new technology with our expertise. Right. That was a bit the idea. And second question was?
How would you define success for 2026?
Oh yeah, I mean, AGE, the Series A, some big customers. We start signing our first big customers. We're very happy. And I mean, we finally see that it's catching on. So the pivot was not, was a good pivot to do.
Can I ask one more question if possible?
Yeah.
Where is your company in its maturity at the moment?
Yeah, so I mean, we did a seed quite some time ago. We've been very frugal. We didn't I mean, even though, we had 10 people kind of. Yeah, so we're still now a seed. And, and so that's why it's going to be hopefully a Series A this year. That's a goal.
Thank you.
Thank you. Shall I yell?
Yeah.
Okay.
Yeah, repeat the question maybe.
Oh, good. Thanks for the talk so far. So I run the agentic AI team for a big insurance company. So
Okay.
this is, well, document extraction is an important capability for us, but it's also a very crowded area. So lots of startups in this space, and even the big providers like Microsoft, for example, provides an Argus package which combines the OCR with the LLM reasoning side. So I guess the question for you is, what is your biggest differentiator, and what do you think you need to crack to get into big enterprises?
Yeah, the biggest differentiator is our model that is specialized. And generally, the solution use generalist model to do this, although I think they might switch at some point. But at the moment, that's our biggest strength, to have a model that is both better than generalist and also smaller. And so we can have running costs that are lower for these companies. And also this possibility to do this we're talking about this model that is with the data of the company. That's also a good thing, because the big one, they might be reluctant to do this and just have the out-of-the-box solution. And grabbing this last percentage, going from, as you know, going from 90 to 95 or to 99 is very valuable. So yeah, that's our biggest thing. And of course, also there's some geopolitical thing. We are, in Europe. We are an European company, so this kind of help as well compared to the big guys, where they say, "Oh, where is my data going? Are you sure that with us it's all private." They know that, there's no funny business. And by the way, we've seen that we won against, proof of concept, and we're against the big ones, and we won in the end. So it makes us pretty hopeful that it will continue.
Hey, great talk, and just curious, what do you see see most people doing for the OCR task for documents that have both a lot of text but also images that are really important for their downstream tasks, like schemas or maps or that kind of stuff.
Yeah, okay, maps is a difficult one. Yeah. I mean, what we do at the moment with the new Markdown is that we describe the image as best as we can. Put a lot of information, yeah. And if it's a plot, we extract the value, basically transform plot into tables to get the value. Now, when it's complex, I mean, sometimes, diagram, like simple workflow, you can actually put it in bullet points, if this happens, you go there, if that. So you can translate it, but there is a limit. At some point, you have a diagram that is too complex, you cannot translate it into text. And for that, we don't have a solution really at the moment. So it will be by probably using more expressive format for representing these things. I guess, what we do already for tables, we switched from pure Markdown tables to HTML because it's a bit more expressive, and LLMs understand it pretty good as well. So I think it will go to a more expressive, which is a bit less nice to handle, because when it's pure text, it's easy to handle, but you have to find a balance between expressivity and ease of use after.
Any other questions?
Yes. Speak loud.
So, how do you process the e-processing and then the GDPR thing? Like, is that sorted out for the company right now?
Yeah, it's because it's private instance. This solves a lot of issues. The second thing that solves issues is that it's an extracting solution. It's not like a chat, solution, and so this also removes a lot of problem. Like, we're not in the high risk category typically, depending on legislation, but in EU we're not high risk. And then there's a bunch of things to be compliant.
Like the SOC 2 compliance, are you guys working on it, or is have you achieved that?
Yeah, I mean we are compliant. They typically send you a lot of questionnaires. And so we are compliant with whatever this big group wants. Now we're also working to have certification to make also this process easier. There's plenty of things you have to be careful, which is interesting. Now we have a whole process to make sure there's no private information in documents that we use for training, no private information leaks out, even though for us, because we're pure extraction, it's impossible that something leaks from the training data. So often these laws, they are thought for the most common applications, which are, chat-based and so on. And us with extraction, we're like, okay, we're going to comply, but there's definitely no issue there. So it tends to be easier, I think, than for other companies on that point. All right. Well, thank you very much, and I'll be happy to talk after.